Hey everybody, welcome back to Math 3. This will be our first video where we actually do some math, and we're going to talk about functions today. We're in 1.1. It's called Review of Functions, and most of this you probably already know for this video, but I wanted to kind of just go over everything. So if you find this video easy and you already know all of it, that's good. All right, so I'm going to get right to work and show you where I'm going to be working. If you notice here, I'm in our playlist, and everything you see me work on today, what I write and things like that, you can find in the lesson notes. All right, so keeping notes is important. I think you should. When we come back face to face, we'll need our notebooks as we study for the exam at the end of the year. All right, so I'm going to go right to work here on the notes, and we're just going to talk about functions and what we know about them, and hopefully this will be a pretty easy one for you. All right, so these are the notes I was talking about that you have access to now. It's called Review of Functions, and I'm going to fill these in as we go. All right, so there's some examples of functions that you may have heard of before. Most of you have heard of some type of function, and what does a function do? Before you get stuck in thinking about functions in terms of just these obscure examples in the coordinate plane and all this stuff, think about something that you already know about. Actually, if you think about a function, it's something that does a job. It has a job to do. An example might be the toaster in your house. A function has an input and an output. What goes in it, the function acts on it, and then you'll have an output. For example, the toaster has an input of bread. The function acts on it. Well, it heats the bread up until it's toast, and the output is a piece of toast. Okay? So the domain of the function would be the bread, the range would be the toast, and something like that. So here's some examples of functions you've heard of before. I'm pretty sure you've heard of the area of a circle. It says the area of a circle is a function of its radius. Yes. Now, the reason I wanted to put this in here, not just to make it complicated. Okay, so this is a squaring function. The radius is your input. You're putting in an r, and the output is an area. Now, another way this could be written in function notation would be a of r. Now, that's why I put this particular example in here, is I thought that it would be a good one to talk about function notation just for a second, although we want to have a whole section on that. So this is what it would be written like. So remember, in functions, the name of the function is the letter here, right? This is the function a. It's an area function. R is the independent variable, which is an input. So this thing takes in a radius, and it puts out an area. What type of function is it? I'm pretty sure you all know. I wish I could ask you that question right now. It's a quadratic, right? Because it's a squaring function. All right. Now, if we come down here, another one, and that's a Math 2 and actually a Math 1 function. So is this one. This is a Math 1 function. Now, we're going to work with this one a lot this year. The number of bacteria in a culture is a function of time. All right, so the function's name is n. Well, that's a smart name for it because it's talking about the number of bacteria. All right, and if we wanted to use the other notation, we'd say n is a function of time, and then we would just write the 50, and we'll copy that, and we'll cheat, because that can get cumbersome getting in there with all those little details. Okay, so that's what it would look like. So you have an input in t right here, and it will give you the number of bacteria. And as you might know, this is an exponential function, right? So those are functions that you may already know. Now, there are expressions that are not functions or equations that are not functions, but we're not going to do that one right now. All right, and if you take a look at something like this, a basic function, x squared, or f of x equals x squared, this is the squaring function, right? And a person could put this into a calculator, and I'm going to use the, of course, I have to go y equals, and then you'll get to here if you have your TI-84, and this is an, oh, it won't work that way. I always try to use the keyboard, and it doesn't do that, you know. So caret 2, And there's my function. And if we wanted to look at this, let me move myself out of the way here. We could see what the graph looks like. And I think we remember what a quadratic function is. That's the parent function, the parabola. And there's your table. 1 goes in, 1 comes out. 2 goes in, it gets squared by the function. It's a squaring function. 4 comes out. 3 goes in, 9 comes out. So what you see in blue here is your range. And what you see in black here is your domain. The graph of the function is all connected. So it's a smooth continuous function. All right, so let me read this definition with you, and we'll kind of get this video wrapped up. I don't like to get them too long here. It says definition of a function. This might sound kind of heavy when you read it, but it's an important definition. So the function f is a rule. Now, in our example, our rule was squaring, right? It's a squaring rule that assigns to each element x in a set A one element called f of x in set B. A minute ago, we saw this is set B, this is set A. And this function has one element for each input. There's exactly one output. That's the definition of a function. All right, another way to look at this would be a mapping. There's your domain A, f acts on it, and you have f of x. So remember, f of x is an output. Just like if I put in A, f of A is an output. A minute ago we had our 1, 1 squared is 1. 2, 2 squared is 4. And that's how that works. And that's going to wrap this video up. That's just a quick introduction to these things. And I hope this was fairly painless. In the next video we're actually going to do some math. So, all right, just make sure you watch this and let it get finished so you can get credit for it.